This is topic 4. This is using system of equations to solve word problems. So, step 1, define your variables. When you define your variables, make sure you define them to be the answer to the question. Alright, so that way when you solve for your variables, you've solved the question. So write a system of equations to represent the situation. Alright, I'm really going to emphasize that I want you to look for totals. Alright, so write this down. That's important. Look for totals. That's going to help you set up your equation. Alright, so then you determine the best method. So if it's in standard form, then you want to use the elimination method. If one of them solved, like a y equals or an x equals, then you're going to use the substitution method. It's probably easiest. Alright, then you solve the system and answer the question that was asked. So here, let's put this on a new page. There we go. Give us some room to work. Now, a cookie store sells 2 kinds of cookies daily. What I do is right off the bat, what is this asking? How many dozen of each kind of cookie? Alright, so x is going to equal the number of, because it says how many, one kind, and then y will equal the number of the other kind. So they sell chocolate chip and white chocolate macadamia. So I'm going to do chocolate chip and number of white chocolate macadamia. Alright, so now I've defined my variables. Next thing I want to do is see how do I combine my variables to get the totals that are in the problem, if there are totals. So it says 85 dozen more chocolate chip were sold than white chocolate. So there's no total there, but the total sales were $1327.50. So I'm going to write equals $1327.50. Alright, I know something has to add up to that. So what adds up to that? The money for the chocolate chip and the money for the macadamia. Well, it was $6.5 for the chocolate chip plus $9 for the macadamia, and that adds up to your total money of $13.27. Now here, this will mess kids up sometimes, but it says 85 dozen more chocolate chip were sold than white. So which is a bigger number, chocolate chip or the white chocolate? Well, it says there were more chocolate chips, so that's the bigger number. So that means x, the chocolate chip, is bigger than the y. So that means you have to add the 85 to the y to get the bigger number x. Alright, so now since we have our system here, 2 equations with 2 variables, and one of them solved for x, I'm just going to use the substitution method. I'm going to plug this right in there. So that gives me 6.5 times y plus 85 plus 9y equals 1327.5. Now I distribute, and from here you should be pretty much home free. So 85 times 6.5 is 552.5. Alright, now I combine like terms, and then I'm going to subtract the negative, I'm going to subtract the 552. Now I just divide by 15.5, and that gives me y equals 50. Since y equals 50, I know that from this equation, x equals 50 plus 85. So then that gives me x equals 135. Alright, and then I should check my answer as well. Alright, so the way that we check our answer on these is just plug in the x and the y, just like we did before. So, certainly works for the second equation because that's how I got my x. Let's try it in the other equation. We're going to do 6.5 times 135 plus 9 times 50 to my calculator, and it does in fact equal 1327 just like it should, 1327.5. So it checks out. So this is our final answer for this problem. All right. Try the second problem here. We have how many type of each coin does she have? So X is going to be number of type 1. So X is number of nickels. And then Y is the number of dimes. Alright, so that way when we solve for X and Y, we've answered the question that they're actually asking. So now we look for totals. She has a total of 45 nickels and a total of $3.85. Okay, so we have money here and just number of nickels and dimes there. So how do we obtain our totals in terms of our variables? Well, this is number and this is number, so number of nickels plus number of dimes equals total number of coins. So that works. And then this one is money. So we have number of nickels times how much they're worth. This gives us the total amount of money from nickels plus the number of dimes times the total money they're worth gives us the total money from dimes. Total money from nickels plus total money from dimes gives us the total amount of money. So now I'm just going to scale this top problem by negative 0.10, and that will allow me to add and use elimination. So we have negative 0.10x minus 0.10y and equals negative 4.5. We add those puppies up and we get negative 0.05. 0.05 plus negative 0.10 is 0.05x equals negative 0.65. So divide both by negative 0.05, and that gives us x equals 13. So x is 13, and then we know that number, using the top equation, 13 plus y equals 45, so then y equals 32. And then it's probably a good idea to check our answer as well. So we're going to do that right here. We're just going to do, since I got this 32 from this equation, it's going to work there. Let's check it with the second one. So 0.05 times 13 plus 0.10 times 32 should equal 385. So you multiply these, that gives you 0.65. Multiply these, that gives you 3.2. Add those up, and you get 3.85, which is exactly what you should get. So this is our correct answer. So 32 dimes and 13 nickels. Alright, just a couple more examples here. Alright, so how many of each kind of ticket did she sell? So X is going to equal the number of, now what kind of tickets are there? There's adult tickets and student tickets. So number of adult tickets. I like to let X stand for the first one and Y stand for the second one, because typically we try to, when we give you the problems, keep them in the same order. Alright, so there we go. We got our variables defined. Make myself a little room here. And now, step 2 is a look for totals. So we have a total of 260 and a total of 700. This is money and this is number. How do we obtain those totals? By combining numbers of tickets of adults and students. Well, this is a total number, so if we just take the number of adults plus the number of students, that gives us the total number of people. Alright, this is money, so if we take the number of adults times the price and add that time to the number of students times the price for them, that should give us the total price or total amount of money made, which is $700. I'm now going to scale this top equation by a -2. That'll cause the y's to cancel. So I got, oops, shouldn't have done that line. -2x, I'm just going to rewrite it right down here, minus 2y equals Negative 2 times 260 is negative 520. So this cancels. That gives me 2x equals 180, so x equals 90. So that should be 90 adult tickets. And then we have x plus y equals 260, so that's 90 plus y equals 260. Subtract 90 from each side, and we get y equals 170. Now, we should, of course, and that's student tickets. We should, of course, check our answer, right? Let's guarantee that we got it right. So I got the 170 from this equation, so that we know that's going to work out. Let's try the second one. 4 times 90 plus 2 times 170 should equal 700. So that's 360 plus 340, and that does in fact equal 700, which means we've done this correctly. Alright, so here's the last problem. This is where it's key to identify defining your variable correctly. Okay, so how much did each case of juice cost? How much did each case of bottled water cost? So x is going to be the cost. So don't just write x equals juice or y equals water. You're going to write x equals the cost of, and the cost of water. Alright, that's a key factor in this problem. So that way when we find our totals, we'll know how to plug in the variables. So they are science and math clubs are doing fundraisers. Math club spent $135 total. So equals 135 is our first total. How do we get that total? 6 cases of juice and 1 case of bottled water. So if we take the cost of the juice and multiply it by the number, and then the cost of the water and multiply it by that number of waters, that gives us the total cost, right? Cost for juice, cost for water, total cost. And we're going to do the same thing with the science club. They spent $110 and 4 cases, so 4 cases times the price for juice plus 2 cases of bottled water there, so we got 2y, and that is our system. Alright, so it's set up like this. Elimination is going to be the easiest method, I think. So I'm going to scale this top equation by negative 2 so that I can get it to cancel with the 2y. So I have negative 12x minus 2y equals negative 270. That gives me negative 8x. That cancels, and this gives me negative 160. Divide both sides by negative 8, and we get x equals 20. Now this one, it doesn't matter if it comes out to a round number, it just so happens to, but that's $20 per case. If it was money, it wouldn't have to be a perfectly round number. So now we're going to say that for the water, we have 6 times the price of the juice plus y, I'm just using the first equation, equals 135. So that's 120 plus y equals 135. So y equals $15 for each case of water. And this is $20 for each case of juice. Alright, now what we are going to do is double check our answer, make sure we did it right. So I got the 15 from that top equation, so I'm going to use the bottom equation. Because I know if I plug these back in, it's just like doing the same math backwards, so I'm pretty much guaranteed to get the right answer there. So let's check and see if it works here. 4 times 20 plus 2 times 15 should equal 110. So 4 times 20 is 80, 2 times 15 is 30, and that equals 110. So that guarantees that I did it right. Alright, so any questions, be sure to write them down in the side. Here's your U-try, and we'll see you next class.